this will work. So this right here, we're going to do it a little bit differently from normal. First, I'm going to introduce you guys to what the new input system is like, because it's super, super duper helpful. And I think it'd be a good idea to kind of like show how useful it is before we delve into like actually working with it. So over here, we have an input, what is it called? It's called like an input action asset. This is just something that you can create and then pull up like the GUI interface and mess around with this to get all of the input settings. You create an action map, and then there's actions, and then you bind actual inputs to these actions. And so an action is kind of just what connects the logic of an input, like what's going to happen in the code, to what's going to happen physically. So like here you can see I have like gamepad, right stick, X. So when you move it, a game controller in the X direction with the right stick, it will trigger this action. Yeah, the actions have different types. They have value and button. Value is something like a control stick, where if it's at neutral position, it's at like 0, 0, a coordinate plane. And then when you just move it, it changes the vector to based on where you've moved it, and you can get that value through the input system. Whereas buttons, things like this one right here, it's just a button. It's down or up. Let's see. We have interactions. Interactions are specific patterns. So like, especially for the buttons, you can do like hold, multi-tap, press, slow tap, or tap. And these are just things that allow you to kind of like control what you want the user to be doing. Do you want them to be holding down the button? Do you want them to just quickly tap the button? And that kind of all gets done on Unity's end. And here I'll just kind of show like a little something. So like how long you need to hold the button down, for example, is stuff that you can set in here. And then Unity handles all of the complicated programming for that. Processors process the value. I'm going to show it with this, I think. Processors process the value that comes from the binding. So like you can have an access dead zone that if you have a game stick and you have a dead zone of like 0.125, you can't like nudge the game stick. You actually have to move it a little bit more. So that's what they're useful for. And bindings are like the actual physical thing that you're doing. So like the right stick on a gamepad, a certain key on the keyboard, that's what those are. And I'll delve into the rest of it when we actually physically do the stuff. I just wanted to like run through the terms with you guys. That way you could have an understanding of what we're about to do. So let's start with making a new Unity project. So I'm going to open up Unity Hub. And we are going to do new project, input workshop, create. And I'd like to remind everyone, if you have access to a game controller, you should get that out. So that way when we get to the game controller bindings, you can connect your game controller to your computer and actually test everything out that we set up. I'm not an expert on how to connect your game controller to the computer, but if you have like a PS4 controller, which I do, just the wire that comes with it, and if you just put it into a USB spot on your computer, it will like instantly work, which is super nice.
Same should be true of Xbox controllers, I believe.
Nice. All right, Unity, you can do it. I believe in you. I didn't actually check which type of Unity this is running, but we'll see what happens. 2020.1 point something.
For like, I think you can get a Pro controller working, but I don't think it's as easy as just plugging it in. I think you
Yeah.
go through a couple of hoops.
I remember trying to get my Joy-Cons to work with the thing, and it was just annoying. But if you don't have a controller, it's fine. There's other things that we'll be doing that don't rely on a controller. So to set it up, this isn't something that's on like a default in Unity. You actually have to change some settings for it. So is there anyone who doesn't have a Unity project open right now that wants me to wait a little bit for? I have the chat open so I can see. All right, no one's saying anything in the chat, so I will go ahead and continue. So once you have the Unity project open, go to the Windows tab and then go down to Package Manager. And then let it load a little bit. So I think by default, it's going to show you the packages that are already in your project. So you're going to want to press this button right here and then go to Unity Registry. And this will show you all of the packages that come with Unity. You're going to want to search for the input system. Currently, it's input system 1.0.0. We are just going to install it right down here. And it will install this to this specific project. It won't do it for any other projects. And it's going to warn you saying that it's going to change the input settings. Just say yes. We want to enable it because we are going to use the new input system. Where did I go? That system did not pop up. So Jack, go to Window, Package Manager. And then Luke, did you switch to the Unity registry? I'll wait a little bit. Gotcha. And then Jack, let me know when you've got it, so that way I'll go on. Open the package. Cool. And then go to Unity Registry, Jack, and search for the input system, and then install it. Cool. So now the input system has been installed. It's important to note that when you do this, what it does and why they warned you about it before is if you've already implemented with things with the previous input system. So like I know in the past we've done like input.getKey down and then like W. That all breaks because this is an entirely new system with entirely new backend stuff. And by installing it to this project, you are essentially overriding the old input system. So if you are doing this in a project that you've already been working on, all of your current input implementation would break. So I recommend making this like one of the first things that you do right off the bat if you know that you're going to support anything more than just keyboard. And even if you are just going to support keyboard, I do recommend using this because, in my opinion, I find it easier to use and just way more helpful. So everyone should have that by now. So now it's time to implement it. Oh, I didn't follow through that. Oh, well. So in the project window over here where you can see all your assets, we're going to make a new asset. So if you right click on that, you go to create, and then down here, it says input actions. We're going to make a new input actions asset. And we can just name this input system asset. And so this gives us the window that we saw earlier. I like to just kind of put it up here with the scene in the game tabs. And so this is the empty version of the input system asset. And so now we've got to fill it in. So here you can add action maps. Action maps are collections of actions. It's useful to have different action maps for different things. So like in the, and here I'll show in the example that I used before, I have one specifically for my debug actions. We use key presses for different debugging purposes. I have one specifically for the UI, and then I have one specifically for controlling the player. You can divvy these up however you want. It's totally up to you. These I'm just going to name actions because we're only going to make one action map right now. And so here, this is where you can start actually making actions. So this first one, new action, let's say we want this to be left. So we're just going to name it left. You can see over here in the properties that the action type is button. If you were using a controller, this would be a value, but we're just going to do keyboard actions first. I think that's probably a good place to start. So we're just going to leave this button. And so in the the binding area, you're going to want to do the path. And so normally you would just like search for like, I want it to be a key, and then, oh my God, look at all the things that have a in their name. That's dumb. Instead, we are going to use this fun little button called listen. It says listening for button. If you press A, it shows you the paths that are activated by pressing whatever it is that you pressed. So on a keyboard, it shows you the A key and any key, because either of those things would be triggered by pressing A. And if you were to press like multiple keys right now, it shows you all of them. And so we're just going to go press A. So now we have the A key binded to the left action. What happens if you just yell out the key you want? Is there voice? Hold on, don't do this. I'm just messing around with Alberto. I want to see if this is something that can work. No, okay, there's no voice controlling. If there was, that would be fun. Actually, yeah, no, there's not. RIP. So we created the A key, which does left, and so now we're just going to do it for right, up, and down. We're going to do it this way first, so that way we can show you an easier way later. And so I'm kind of moving fast, but essentially what I'm doing is I'm just doing what we did for left, but for D, W, and S. They've all got buttons, and they've all got their paths. Cool. And so now let's do this. I'm going to save the asset. There's a little save asset button here. You'll either need to press that whenever you want to save your changes, or you can do auto save. Totally up to you. I usually just press the save asset button. But the most important thing to do, I would say, is when you click your input system asset, on the right side here, it says generate C# class. You're going to want to press that because by doing this, it actually will create a C# file, and we're going to press apply. And this file is essentially just a code version of everything that you're doing here. And by having the C# class, you are able to reference the input system asset through code in an easier way than you otherwise would. So I'm gonna go back to the scene view, and now we're going to implement some simple movement. So what I'm gonna do is I'm just gonna set up the scene. I'm gonna put a cube here. And then we've done this before. We're gonna create a capsule. And we are going to give the capsule a rigid body. We're going to give it constraints on the rotation so that way he doesn't fall down. And then we're going to give it a movement script. And then we'll open up that movement script. That was kind of fast. Is there anyone who got lost there? All right, looks like no one got lost, so we'll keep on going. So in the movement script, what we're going to need to do is we're going to need to reference our input system. I think we named it input system asset, at least I did. So you're going to want to make a private variable of type input system asset, and then I'm just going to name it inputs. And so this is just an instance of your input system. Yeah. So in start, or you can do this in awake, we're going to assign inputs to a new version of input system asset. And then we are going to get the actions specifically. We're essentially going to be assigning the logic to the actions right now. So if you go to inputs dot, and then whatever you named your action map in, oh, let this load, in here, it'll be input dot your action map name. And then dot whatever the action is that we're doing first, I'll do left first, dot performed. And performed is just like you've done the action in its entirety. Then this is where it gets a little bit weird, but it's kind of cool. You do plus equals, and then you can name this whatever. I name it CTX because that's what Brackeys did, and Brackeys is great. This is short for context. And then you would do, let's do move left. I think that's probably the easiest way to start. Move left is a function that we're going to create right now. So we're going to do void move left. And then we're just going to continue doing the typical movement scripts that we've been doing in the past, where we have a reference to the rigid body. And then with this rigid body, we do the velocity. I think we set the velocity. What is it that we do? Hey, Will, you remember how to set how we make it move?
I think velocity's right. Let me pull it up. Let me pull something up.
All right. I think it is.
You should have a variable for the left velocity, and then in your fixed update, combine all the x and y velocities into one velocity.
That sounds right.
That makes sense. I am curious though if I can't look at tally for this because I didn't. All right.
You can't assign to the velocity.x.
Oh, I can't? Okay, cool.
So make like a new variable, a new float called x velocity.
Do you have to do vector 3 for this?
Float.
Look, float. All right. X
I was just saying, since I don't think you could have just set the velocity.
Yeah. Yeah, I think
in your fixed update, do like velocity is equal to new vector 3, velocity x, velocity y, velocity z.
Gotcha. Okay. Actually, hold up. I want to see something. Velocity equals new vector 3 rigid body dot r. Let's go 5. Right up. Velocity dot y.
Yeah, that works too.
Yeah, I'm just testing something out with this. All right, I like this a lot more because this is event-based, and event-based stuff is fun. So I'm also going to get rid of that. I kind of jumped around right there because I jumped around in my mind. What we're doing with this is we are essentially just doing, we're calling the move left function with when you perform the left action. And the move left function is assigning the rigid body's velocity to a vector where its x value is changing, or its x value is now 5. And its y and z velocities are what they currently are. So when we press left, we will move 5 in the x direction, velocity-wise. It's probably a smart idea to make this a variable called speed. Is there a using statement I'm missing? Adam, did you turn, oh, hold on a second. Did you turn your input system asset into a C# class? Make sure you do that. If you don't turn it into the C# class, you're not able to access it through code like that. You'd have to make like a public variable and then drag the system into it. But yeah, I'm gonna do speed. So that's how you get it to move left, and then we'll just do the same thing. Performed. Move right. Yeah, this is terrible code, but I think this is the way I want to do this, for now at least. So it's move right is basically the same as move left, except I'm thinking move left should probably be negative speed. Sounds right to me. This way it's just the opposite direction of what move right will be. And then easy way to do this is to just copy and paste this and change left to up. Oh, I can spell. And right to down. And then move left to move up and move right to move down. And then I'm just going to do this first. Move up. We're going to make this speed. And then move down. Negative speed. All right, cool. So running through what we just did, we have left, right, up, and down mapped to move left, move right, move up, move down. And we're setting the velocity to either negative speed in the x direction, positive speed in the x direction, positive in the y direction, positive speed in the y direction, or negative speed in the y direction. And then speed is a float variable that we have up here. I would set, yeah, you should set that equal to public so that way you can change it in the game, like in your editor, and not have to change it in the code. So this is just a really simple movement script, and we're going to optimize this as the workshop goes on, but this works decently well for now. And so if this looks good to everyone, I'm going to move on. Cool. So we're here. We have the capsule. The capsule has the movement script. You need to drag your rigid body into there, so that way I can reference the rigid body. I'm just going to move all that down so that way we can actually see everything. I need to be aware of where our positive values are. The z direction is the other direction in the plane and not the y direction. Okay, we're just going to go back into the code because I made an oopsies. your up and down should be in the Z axis, not the Y axis. Make sure you change the Y back to like rb.velocity.y, and then your Z is speed. And so I'll go back here. Now that that's working, this should work. Oh, come on. I'm maximized. I don't want to be maximized. I want to be looking at it through the scene view. Huh. Oh, I did it again. Okay, so this is something that I realize that I do every single time. And the first time that I did this, it was confusing me for about 2 hours. There is an on switch, and it's important to press this on switch. So you can do inputs.enable in your start method. This will enable all of the actions in your input system. You could further narrow this down if you don't want certain actions to be triggered during this. So like if you did input.actions.enable, that works. If you wanted to do input.left.enable, that also works. But since we're not really doing anything important, we can do inputs.enable, and that just enables our entire input system, which is cool. So now that that's there, our inputs should be enabled, and we should be able to control our character. Oh, that's fun. It only happens the once. Oh, it only happens the once because we're doing velocity. That doesn't matter. This isn't about how to make something move around. So there's better ways to make movement. You could be, we're setting to click button. No. That is part of it, Jack. And heck, we can change that now, actually. Let's see if that works. Let me just see. I'm curious if it works. You guys don't have to follow this. I'm just curious to know if that will fix the problem. No, adding hold means that there's like a delay. So like this is immediate. This I'm pressing, delay, because I have to hold down the button. If you just tap it, it doesn't do that. Yeah. It's because what we're doing is because what a button is we've performed the action of pressing the button. And like in here we have performed. We can only perform that once. And so there's probably, there's not like a hold, started, performed. Yeah, so like if we had done started, yeah, so there's no way to get around that. The way we implemented it is just kind of half an A press. Yeah, you can do that. You can like rapidly press A to do it. It's just the way we implemented it. We set the velocity when we probably should have been we probably should have been adding to the position. But it's fine. This isn't how to make something move workshop. This is just getting inputs working workshop. So we've got a very simple input system working. Now we should probably make this cleaner because this is kind of disgusting. We can go to the input system. The first thing that we can do is we can kind of get all of this under one roof. As opposed to having 4 actions, we can make 1 action. And we can name this action movement. And we want movement, instead of a button, we want it to be a value. And so the control, when you have a value, this means that we'll now be getting a numerical value whenever the input is done. And the numerical value that we're going to want is a vector 2 because we're moving in a 2D plane. And the easiest way to kind of visualize this, I would say, is to start off with the joystick functionality. So if you have a game controller, I recommend plugging it into your computer and then going into the path and then doing listen. And then I'm going to use the left stick on this. And then up pops left stick. If you do PS4 controller, this will only work with PS4. If you do gamepad, this will work with all game controllers. This will work on Switch, this will work on PS4, this will work on Xbox. So definitely do gamepad so that way you can have more usability with your program. However, not everyone has a game controller. So we are also going to include an option for keyboard controls. And so we want to add another binding. You can have multiple bindings under one action. And the binding that we're going to add is, instead of a binding, we're going to do the 2D vector composite. What this does is this allows us to have multiple bindings under one thing. So that way we can have the up key, the down key, the left key, the right key still map to this movement vector 2. So now if you bind your W key to up, your D key, or your S key to down, left A, right D, WASD will now also do the same thing that a gamepad will do. It's just going to be more analog digital, because with a game or with a stick, you can do like a half like movement and you can kind of like do crawling. Whereas with keys, it's either up or down. There's no in between. And so these will be immediate like 1 values. Whereas with a stick, you may have like a 1/2 or a 1/3 value. Cool. And so now that we've got all of these under the 2D vector, and you can see it has analog, digital, normalized, or digital. I don't honestly know the difference between digital, normalized, and digital, but I'm sure just leave the default values there. And now we can reference this action instead of all of these 4 actions here. Make sure you save your asset. And then you can go back into your code for movement. And we're just gonna comment out all of these. Oh, Alberto, what's the difference?
So it's a vector 2. So each axis is going to be a value between -1 and 1. And so your x can be -1 and your y can be -1. If it's not normalized, then the magnitude of -1 and -1 is going to be like the square root of 1 plus 1, which is more than 1.
Ew.
Which means if you press like A and W, you're going to be going faster because you're like combining your you're combining your speeds.
Mm-hmm.
If it's normalized, it's going to make sure that the magnitude is always less than 1. So that way you can be pressing A and W, but you're always going to be going like as fast as you can go in just one direction.
Mm-hmm. Yeah, you avoid the hit cone problems.
Yeah.
Circular versus regular. Yeah. Cool. And so now we're going to do something similar to what we did here with the input.actions, but instead of left, we're doing movement performed. We still do plus equals, context. But now we can't just do a function here, because with this, we've got, once it loads, we've got a value, and the value is a vector 2, and we want to use this value. So we are going to do, let me make sure I have the context right. You can get the value for it by doing ctx.readValue, angle brackets, vector 2. And this gives you the vector 2 that we are getting from our movement. And so now what we're going to do is, Alberto, I'm going to take the idea and do the update thing. We're going to make a public, no, not a public vector 2. we're doing a private vector2 named move. And we are going to, I think I can do this here. Let me test this out. Yeah, you can do that there. And you can assign move to context.readValue vector2. And so this will set this vector2 to that. And so we're going to get rid of this update method. And we're going to start doing everything in fixed update. That's a better one. And then we can do rb.velocity equals move. And so what this will do is on tick, the velocity of the player will be the vector2 that you get from your inputs. But I think this is going to be, like Alberto mentioned, really, really small because it's being normalized. So you'll want to multiply it by speed. Is there anyone that got lost there and wants me to show them something that they might have missed? Normalizing and scaling a vector. Yes, that is what normalizing means. Cool. So now this should work. So if you go back to your game, and then you go here. First, I'm going to try it with my, oh, well, this is because we're doing it on fixed update and it is currently not reading anything. So there's a little, here's how I normally get around this. I usually do new vector3. There might be a better way to do this. If there is, please let me know. New vector3 move.x, move.y, and then rb.velocity.z. And that way this just keeps its z velocity at all times, which with gravity would make it the gravity velocity, but still adds your move x and move y to it. Y is vertical. Thank you, Adam.
Don't you need to do z again?
Yes, you are absolutely correct. Thank you for letting me know about that because I forgot. Yes, so as Adam pointed out, the y direction is the vertical direction in this scene. So you're going to want the velocity in the y direction to be the one that doesn't get changed. And you want your x and your z velocities to be changed by move. And then, yeah, because you don't want to alter or affect that, you'll want to multiply these by speed. Right there. If you did speed on the outside, you would also be speeding up your fall speed, which you may or may not want to do, totally up to you. So now we can go here. It should have the changes. When we press play, now it falls down normally. If I go A, we're moving. If we go D, we're moving. Oh, I know. So right now, if you do this, you're just going to keep moving even after you've pressed. And that's because we don't have anything for canceling. So we're going to want to cancel it. Where do I do this? So on back to the code, inputs.actions.movement.canceled, CTX, this, you're going to want to set your move to vector2.0. And what this will do is this will set this vector to 0, a 0 vector, So that way you're not moving when you're not pressing the button. Canceled is what happens when you finish the action. I have to change that in the notes. I'll do that later. And so now when we start it up, hopefully this time, it'll only move when you're pressing the button. And so also, because we did do the controller, if you take your controller, if you have it, and move around with the stick, you can see movement with a game controller. And like I mentioned, if you just kind of like nudge the stick, he kind of crawls. And if you go full on, he'll speed. And so that's how you have the analog speed. Oh, that's cool. You can also use both at the same time if you wanted to, which is a little glitchy, but you know, it's how it goes. Works without that in controller being actually its controller going back to 0. Oh, that's cool. I didn't know that, Jack. Jack pointed out that you don't need the canceling in the controller because the controller does go back to 0. Although I will say that it's nicer to have that than to not have that. Yeah. Well, that is cool to know. Cool. That's movement. Is there something else I wanted to do on here? I think that covers most of it. Back up. True. Jack pointed out how the stick on the controller can flick back a bit, and that would cause like a little bit of sliding if you didn't have the canceled in there. Yeah. Let's see. I've gone through. That's like the main thing of the input system. Honestly, it's not super difficult. I just wanted to share it with everyone because I discovered that like in the summer, and it's super duper cool. And it allows you to be way more flexible with your games. Let's see. You can also do. Let's try something else. We're not gonna like. We'll see what we can do. Let's call this one jump. And for jumping, we want it to be special. We want you to have to press 2 buttons in order to jump. We're not going to make this easy for you to jump. And so we're going to get rid of the binding that comes with it at first. And we're going to instead add a button with 1 modifier composite. So the button with 1 modifier means that now instead of having to just press 1 button, you have to press 2 buttons. Or you have to do a button and something else with it. And so for the button, let's keep this on the keyboard still. And let's make the button the spacebar. And we'll make the modifier, we can make it another button for now. Let's make it Y. And so with this, you should have to press spacebar and Y at the same time in order to jump. We're going to save this. And then we're going to go back to our movement script over here. And we're going to do inputs.actions.jump .performed plus equals CTX. And we're just going to call a jump method that we haven't created yet. And so then down here, we're going to do void jump. And then the jump method is just going to do velocity plus equals new vector 3, 0. Let's make it speed just to keep it simple. This. And so this is super simple jumping where when you perform the jump button, it will do the jump action. But since we made it the button with 1 modifier, you're going to have to press space and Y at the same time in order to make that happen. So let's see if that works. I want this to be side to side. So if I press space, nothing happens. If I press Y, nothing happens. If I press both, you have your jump. And so you can combine this with more than just buttons, from what I understand. I haven't actually done this before, so I'm finding this pretty cool to see. So like, I can't do mouse things. Let's do the stick. So if I do this, I'm gonna do it with my controller. And then we're also going to use X, button south. Yeah. So now I just made the button with one modifier. You have to press the bottom button on the game controller plus move the left stick in the X direction in order to jump. So pressing X does nothing, pressing or moving in the X direction does something, but if you do this, oh Lord, that's fun. I think he's gone. Practical use for something like sprinting mechanics. Yes, a practical use for this would be like sprinting mechanics. Well, he disappeared. But yeah, so like if you wanted to have sprinting, where by pressing in the movement while also pressing like shift key, then you can increase the speed. And so it's a fun, easy way to do it. Essentially, like you just saw, once you have the code to just like do the performed and the canceled stuff, you don't need to touch it, because then you can just kind of keep all of your changes to the input system in the input action section. And so that's really cool. And this works for, from what I understand, pretty much any input that Unity can do. I'm going to show you guys this because I'm pretty proud of it. I just got this working yesterday. This is the thing I'm working on for the libraries. So my issue last time. Do I know how to add screen mouse clicks? So Alberto, for UI, what I would recommend doing is honestly just keeping it with buttons. You wouldn't want to use the input system for buttons and UI stuff, if that's what you mean. Feel free to unmute if you have like a more specific question.
Well, I just mean like if you press the escape key to open up the pause menu, and you have your mouse now on the screen to click the menu buttons.
Okay.
Like those are like when you have a canvas and a button you can have a button in the canvas that has actions based on like clicking it.
Mm-hmm.
That didn't work the last time I tried using the input, and then I couldn't. It was like just too big brain for me to figure out how to add clicking to the thing.
What I think, so I've never tried this before, so I'm just guessing based on what I can see right here. In the Unity's API, there's something called cursor.visible. So what I'm assuming you might be able to do is kind of like how we had, I'll go back into the code here, like the jump button, you would have like cursor visible, and that would just be mapped to your escape key. And it would call the cursor visible method, and the cursor visible method would just do, and heck, I don't even think you need to make it this complex. I'm pretty sure you can inline this. I think you can do cursor.visible equals true. And I think that will allow you to start clicking things.
Well, that shows the cursor, which, I mean, yeah, but it doesn't make the HUD work. Like the canvas input just doesn't work anymore because the canvas input uses the old input system.
Huh. If I'm being honest, I don't really know. I haven't done much with it. I do know that with this, it works fine, but I never like hide the mouse in this thing. So like this is a working HUD. Or at least it does whenever I try to do it. Oh, I broke it, I think. That's nice. I'll have to let Owen know about that. So I don't know, if I'm being honest. But yeah, it's something that I guess I could look into at some point if you wanna know about that.
Nice.
But with this, I wanted to show we have touchscreen controls, keyboard controls, and controller controls with this. And I can actually demonstrate all three of them right here. If we go up, then it zooms in on the selected person. If we go back or down arrow key, then it zooms out. The left and right arrow keys select a person. You can see by like the little ring. You can move them around with WASD. You can also do this with the controller by moving around with the right stick. You can zoom in by going up on the left stick. You can zoom out by going down on the left stick. And you can select another person by going left and right on the left stick. Or we can use touch controls, and there's something that I've enabled called Touch Simulation. This is a script that I'm pretty sure already exists. It essentially lets you test touch controls in Unity without having to like run the thing on a touch device. And so if I just click, then it'll think that I'm tapping the screen, which is probably why that UI broke. So if I click and then like swipe up, it zooms in. When I click and swipe down, it zooms out. And then when I tap on either side of the screen, I think it's like a 2/6 of the screen boundary, it goes left and right with the person select. And if I tap in the middle, it doesn't do anything because there's like a little dead zone there. So that way I can do the swiping. But yeah, all of that is with, just ignore the errors, all of that is with the input system. I don't do anything super duper fancy in the code. I just do some pretty simple like tapping. I do some hacky stuff with the swiping, which I guess I can show off a little bit. I don't recommend doing this, and I have this in the outline if you're really curious at looking at this again. But if you look, like zoom out is a button, but I have swipe down, and that's just because I use like dead zones and inverting to convert the swipe down into a button action. It's disgusting, and I don't think that's what you should be doing, but it works, so I did it. So that's fun. Yeah, and also along the lines of hacky, you can also use gamepad sticks as buttons. And it's just essentially you add a dead zone, so that way it's only when the stick is like all the way to the side, you activate the button press. And yeah, that's it. It was a super simple thing. I know if anyone has any questions or want to know like how to do certain things, we can do that. If you have any questions, you can ask it. We're scheduled for another hour if you want to be here. So all up to you guys, but thank you for coming.
New record, shortest workshop ever.
Heyo.